In this video, we'll talk about ways to produce data by sampling. So when researchers want to answer a question about a large group of individuals, like a population, they can't measure everyone in that population, so they measure a subset of the individuals. And that represents the entire population, and we call that a sample. So, for instance, when they're doing all those surveys to see which presidential candidate is ahead in a presidential election, well, they don't talk to every single American voter that there is. They do a sample of American voters, and they use that to represent everyone. And then they use statistical techniques to make conclusions about the population based on the sample. We'll talk about that later on in the course. So there's some really bad sampling designs you can do, and they're out there and you see them everywhere. One of them is what we call voluntary response sampling. So you allow individuals to choose to be in the sample or not. So you could maybe have a website where only the people who go to that website and choose to click on the thing are included in the sample. There's a lot of bias in that. Convenience sampling is when you take individuals that are easiest to reach. So maybe if you wanted to do a survey on TCC's campus, you just stood in the cafeteria and talked to people there, and that's all you talked to because it's easy to get people there. But both of those are biased because they're going to favor certain outcomes over other outcomes. So here's a great example of really biased survey using voluntary response. So this woman, Sherry Height, wrote a book called Women in Love. And she sent out questionnaires to 100,000 women asking questions, and only 4.5% responded. And she wrote her book totally based on those 4.5%. And then came to these conclusions that women were fed up with men and eager to fight them. Anger became the theme of her book because angry women were more likely to respond. People who have really strong opinions are the most likely to respond to questionnaires like that. Convenience sampling. If you sample mice from a large cage to study how the drug affects physical activity, and the lab assistant just reaches into the cage to take the mice one at a time until he's got 10, well, the ones that are most likely to be chosen are probably the ones that are easiest to grab. So they'll be the ones that are lethargic, that aren't moving around much. And that's going to bias the results towards, oh, this drug causes them to be lethargic. Simple random sampling is what we really want to be doing with gathering data. Because in simple random sampling, each individual in the population has the same chance of being chosen. So, and each group of individuals of any size n has the same chance of being selected. It's like drawing names out of a hat, using a table of random digits, which there is one in your book. We won't use it because it's cumbersome and difficult to use. We'll do things on the calculator or by computer software, but that is one way to do it. Computer software is the most convenient to us and very accurate in being random. So the way you choose a simple random sample is you label each individual in the population. Okay, and usually that's done with numbers. And then you use, they say table B to select labels at random. Table B is the table of random digits in the back of your book. But you also use computer software to choose random numbers between, say you have 2,000 in your population, between 1 and 2,000. Any number of ways to get, what you want to get is the sample that you want to draw out, the number of individuals you want to use to collect your data from. You want to get that many at random out of the total population of numbers that you have. So a probability sample is a sample that is chosen by chance. And you have to know what samples are possible and what chance each possible sample has of being selected. But you know that with a simple random sample, and this is the abbreviation we use for simple random sample, right here, SRS, you'll see that a lot. That gives each member of the population an equal chance to be selected. Now, stratified random sample is another way of getting a random sample. In some applications, you really want to do a stratified one. And what you do is you divide the population of similar individuals together, and you call them strata. And then you choose a random sample from each stratum. So stratum is the singular, strata is the plural, and when you use strata, it's called stratified. And you put all those together to get your full sample. Okay, you might want to do this if you want to make sure that you have representation from both men and women, so you could do a simple random sample of the men and a simple random sample of the women. You might do, at a four-year college, you might do freshmen, sophomore, juniors, and seniors. So those are times when you might use a stratified random sample. So here's an example. A university with the following student demographics. 55% of them are undergraduate, 20% are graduate, 5% are in first professional, and 20% are in special programs. And a stratified random sample of 100 students could be chosen by taking 55 undergraduates, 20 graduates, 5 first professional, and 20 special students. And in those populations, then you pull simple random samples of that size from each of those populations. And you combine those to get your 100 students. The last thing we're going to talk about is multistage sampling. When you do several stages of sampling to get to where you want to. Okay? And that's useful for really large-scale sample surveys. And at each stage, they could be simple random samples. Often they're stratified, but they could include other random sampling techniques. And these are less often used, and we don't talk about them as much, but they're perfectly valid in certain instances to use these kinds of things, like cluster samples, systematic sampling, and random digit dialing. And those are all in your book for you to read about further.